Hello students, in this lecture we are going to discuss derivatives and its applications. In last lecture we have seen limit continuity and differentiability where we have defined the derivative of a function. Okay, so what is derivative of a function? Okay, so let us say y is equal to fx is a function. We want to find its derivative at point x is equal to a. So we write f dash a. That means derivative of fx at x is equal to a. So what does it mean? It means that if we draw a tangent at point x is equal to a on y is equal to fx, then f dash a will give the slope of a tangent, at x is equal to a. This is one of the definition, and we can also say it gives us the rate of change of a, rate of change of fx at x is equal to a. Rate of change of fx with respect to x at point x is equal to a. Okay, so using first principle we can define f dash a as limit x tends to 0. In place of x, let me write h tends to 0, f a plus h minus f a upon h. Okay, so this is called first principle. We have also seen some of the useful formulas for finding the derivative of a function. Okay, now we will be looking at some small concepts. Angle between two curves. So let us have a two curve fx, y is equal to fx and y is equal to gx are two curves which intersect at point where fx is equal to gx, right? So let us name the point as x is equal to a, point of intersection. This is the point of intersection. Say, so at that point we have to find what is the angle between two curves. Then it means that if we draw tangents to those two curves, y is equal to fx and y is equal to gx at point x is equal to a, then what is the angle between two tangents? So angle between two curves is equal to angle between tangents at their point of intersection, right? So we have f dash a as slope of tangent at x is equal to a for curve y is equal to fx, and similarly z dash a as slope of tangent for y is equal to gx. So we have tan theta, where theta is angle between curves fx and gx as, so we can write, say if the slope of one tangent is m1 and another is m2, then we can write the angle between these two curves as theta is equal to tan inverse m1 minus m2 upon 1 plus m1 m2, right? We have learned this in coordinate geometry. So we can write tan theta as, this is the slope of first tangent and this is the slope of another tangent. So f dash a minus g dash a upon 1 plus f dash a g dash a modulus, right? So this how we can calculate the angle between two curves. Now next, concept of monotonicity, that is increasing and decreasing. So we have f dash x means rate of change of fx with respect to x, right? So if f dash x is greater than 0 in some region, then we can say that the function is fx is strictly increasing. Okay, and if say f dash x is less than 0, then we can say fx is strictly decreasing. If it is greater than equal to 0, then just increasing or increasing. And if f dash x is less than equal to 0, then we can write as just decreasing or decreasing. So these are the conditions for functions to be increasing and decreasing, right? So now next we have the concept of maxima and minima of a function. Suppose a function fx is something like this, y is equal to fx. Then at point this, say this point x is equal to a, this function attains a maximum value which is fa. So the function fx attains a maximum value at x is equal to a. So suppose we want to find a maxima and minima for a function which is differentiable in its domains. So for fx to be differentiable in its domain, see, when the function is differentiable, then at the point of maxima or say if minima occurs, this is the point of minimum. So at a point of maximum or at a point of minimum, the slope of tangent is 0 at that point because this is parallel to x-axis, isn't it? So we have f dash x is equal to 0. So first we solve for this equation f dash x is equal to 0. Then after this we get candidates for maximum or minimum. So let us say we get x is equal to a. So we have to check whether at x is equal to a maximum is occurring or minimum is occurring, right? So you put just a point, you substitute just a point which is less than a on that function and see what is the value of this point. And also you put a point which is just greater than a and find the value of that point. And you also find the value of function at x is equal to a. So if a minus, right, a minus h, something a minus h is less than if a is less than if a plus h. Okay, so if this condition appears, then at x is equal to a we have maximum. And say if we have minimum at this point, then at some point after we have this is not exactly the case. See, let us draw the figure again for maximum and minimum. This is the case of maxima and this is the case of minima. So say at x is equal to a, we have a candidate for maximum or minimum. So if a is at x is equal to a, maximum is occurring, then before a, before if we take any point a minus h, then we will be getting the value which is less than this value, and after a, say if we take a plus h, say this is h1, this is h2, any number, then this value is also less than at whatever the value is at f is equal to a, if x is at x is equal to a. So for maximum we have the condition if a minus h is less than equal to f a, and if a plus h is also less than equal to f a. The sign of equality holds as h tends to 0. Equality holds if h tends to 0, because this is continuous at this point. So equality will hold at that point, right? Again, if you see for minimum, then if a is less than if a minus h less than equal to, as well as if a is less than equal to if a plus h. That means minimum is occurring. Here also equality holds when h tends to 0. Now this is the basics of maxima and minima. Using derivative test we can also see whether the function is at maximum or minimum. Say if we are taking before maxima, then the function, if you see what is the nature of the curve before maximum, then the curve is increasing, and after maximum the curve is decreasing. So if dash a minus something is less than 0, that is decreasing, and f dash a plus is increasing greater than 0, then we have minimum, right? Say this is decreasing and this is increasing, so minimum. And if f dash a plus is greater than 0, increasing, and f dash a minus is less than 0, that is decreasing, then we have maximum. So these we have learned the two tests for maximum and minimum. Now the third test is second order derivative test, which is basically double dash test. So say we have one maximum and one minimum curve. So this is maximum, here the maximum is occurring, and here the minimum is occurring. So let us find f dash, we will be finding f double dash a. If f double dash a is greater than 0, that means rate of change of f dash x is positive. Rate of change of f dash x is positive at x is equal to a, which means that the curve is concave upward. Okay, concave upward means minimum at x is equal to a, right? And if f double dash a is less than 0, then rate of change of f dash x at x is equal to a is negative, right? So we have the nature of curve, that is fx is, the curve is concave downward. This is concave downward, or we can say maximum at x is equal to a, right? So these are the three tests which we can perform, any of these, for checking the maximum and minimum and finding the value of maximum and minimum for a differentiable function, right? Okay, so there are two important theorems further. The first is Rolle's theorem. These two theorems are also applicable for a function which is differentiable. Okay, say if a function is differentiable, if fx is differentiable in closed interval a to b, right? Say we have a function which is differentiable in interval a to b, and fa is equal to fb. Say fa is equal to fb. So we have a function like this, something like this, which is differentiable in this interval, and also fa is equal to fb. Then there must exist a point C such that C lies in the interval a to b, okay, and f dash c is equal to 0. That means there must lie a point C at which slope of tangent is 0. Okay, so this is the Rawls theorem. Again we have next theorem, which is the modified version of Rawls theorem, known as Lagrange's mean value theorem. Okay, so here also fx is a continuous and a differentiable function in a region a to b, closed interval a to b. So fx is continuous and differentiable in closed interval a to b. Then we have, say, like this, and say this is a and this is interval b. Then the theorem tells that then there must exist a point C in the interval a to b such that f dash c is equal to fb minus fa upon b minus a. That is, there must exist a point C where the slope of tangent is equal to the slope of this secant. Okay, so this is the modified version of Rawls theorem, where fb is equal to fa and we are getting the slope of tangent as 0. So these are the two important theorems. Now, using derivative, we can also do some approximations. Suppose we have to find the value of 3.01 to the power 4, right? Then using derivative we can find the approx value of this number. Okay, so let us name a function fx is equal to x to the power 4. That is, this is y, say. Then, and we have, say, delta x is equal to 0.01, right? So y is equal to, we can write x to the power 4, or we can write dy upon dx is equal to 4x cube, which is f dash x, or we have dy is equal to 4x cube dx. So we can write simply delta y is equal to 4x cube delta x. This is actually the approximation here. We are approximating dy as a delta y, as this delta x is very small, because here delta x is 0.01, right? So we can approximate as delta x as dx and delta y as dy. So we have 3.01 to the power 4 is y plus delta y, right? Which is equal to, y is 3 to the power 4 and delta y is 4x cube, that is 4 times 3 to the power 3 into delta x, which is 0.01. Now 3 to the power 8 is 81 plus 4 times 27, which is 108 times 0.01. So we have 82.08 as the approx value of 3.01. So with this I conclude the lecture. and next we will be going to solve the problems. Okay, thank you.